Hi friends, welcome to my YouTube channel. In this video, we will see about combustion chamber of the gas turbine engine. So this is a typical representation of the gas turbine engine combustion chamber. Here we can clearly see the main components of the combustion chamber. So here the fuel inlet, injector, solar vents. So first I will explain what's the main purpose of the injector. Injector or atomizer is a device. So this is the main important component of the combustion chamber. So fuel will be injected through the this injector only. So next, solar vents. So gaseous fuel we can call as injector, whereas for the liquid fuel the injector is called as a atomizer. Okay. In upcoming videos I will explain detail about the atomizer. Next, solar vents. The main purpose of the solar vents is to create the recirculation zone or properly mixing the air fuel mixture in the primary zone of the combustion. Yeah, this is the primary zone we can call or the combustion zone. So based on this recirculation, fuel and air properly mix and create the combustion. I mean it will properly burn in the combustion zone. So we have three different zones in the entire combustion chamber. First is combustion zone, that we can call as a primary zone of the combustion chamber also. Whereas second is the mixing zone, third one is the dilution zone. Here we can see the air is split into different flow paths. One is primary air. So the primary air mainly for the combustion purpose. Here we can see the primary air entering into the main combustion chamber, combustion zone. Okay, this is the one like primary air. Whereas further the air is bypassing through the liner, then it is mixing into the combustion chamber. Here we can see the secondary air. So here we can see three different lines. They are splitting the three different of rows of air into the mixing zone. Here further it will mix in the combustion chamber. It will enhance the combustion as well as it will cool down the liner temperature. Further, this is a dilution zone. In order to maintain certain temperature, which is like intake temperature of the turbine, we are mixing further air to dilute the combustion temperature. That means hot gas temperature. Then the hot gas is further entering into the turbine here. This is the towards the gas turbine. So this is a simple explanation of the combustion chamber. So here I explained about the fuel inlet, injector, solar vents, primary zone or combustion zone, mixing zone or and dilution zone. So this is the typical representation of the gas turbine engine. So here I will stop in the explanation of the theoretical basis. Then I will move to the design of this combustion chamber using solid software. Here we will see about automation. So in previous part of video I explained about injector for the gaseous fuel, whereas for the liquid fuel atomizer. Atomizer is the device which converts volume of liquid into multiplicity of drops. So that is the device which convert volume of liquid into the multiplicity of drops. The process, the converting volume of liquid into a multiplicity of droplet, spray is known as the atomization. Here in this image we can clearly see about atomization process. Here the liquid core is break into the bigger ligament, further bigger ligament into bigger droplets, whereas further primary bigger droplet into the very finer droplet. The process is secondary breakup. Secondary breakup is the process in which bigger droplet is further breaks into very finer droplet. This is known as secondary breakups. So the entire process is known as automation. Let's look into what are the parameter which affect the automation. First is geometrical parameter. So atomizer geometrical parameter such as atomizer diameter, or it's like external or internal mixing atomizer, etc. In the second parameter is operating parameter. So supply pressure of liquid or supply pressure of air, atomizing air, etc. In third important parameter is thermophysical property of the fluids such as density, viscosity, temperature, surface tension. So these are the three different key parameters which affect the automation process. First is geometrical, second is operating parameter, third one is thermophysical property of the fluids. Okay, next point. Here I would like to explain about classification of the atomizer. First one is single fluid atomizer. Here we can see only liquid is used for the atomization purpose. So here only one liquid, there is no additional air in this atomizer, known as the single fluid atomizer. Next one is the twin fluid atomizer. Here we will use liquid and air for the atomization process. It further classified into internal mixing atomizer, external mixing atomizer. Here we can see I already explained here. Twin fluid atomizer is nothing but liquid as well as the gas for the atomization purpose. Here this is the internal mixing atomizer. Here we can clearly see both liquid as well as air mixing inside the injector itself. So here it will mix, so it will come out as a spray like this. This process known as the atomization process in internal mixing atomizer. Whereas in external mixing atomizer, both liquid here such as water as well as air mixing at exit of the atomizer. So here it is mixing, so this is known as the external mixing atomizer. So there are many application of the spray such as spray painting, spray drying, agricultural spray, spray cleaning, liquid fuel combustion, and drug delivery. Here I already explained about the combustion chamber where we can use this liquid atomizer for the fuel to create a finer spray for the combustion purpose. So this is the overall view about the atomizer. First I will explain about atomization, then the process. So primary, secondary, then what are the important parameters which affect the atomization, then classification, single fluid atomizer, twin fluid atomizer. Further, twin fluid atomizer classified into internal as well as external mixing, important application of the spray, then where our injector is going to use in the combustion chamber. Then I will move to the design of the combustion chamber. Now we will start the designing part of the combustion chamber through the solid edge software. Okay, so this is the student version of the solid edge. So if you are a student, you can download it freely for the teaching purpose or learning purpose only. Okay, let's start with the new part, isometric. First I will design the injector, or sorry, atomizer. Okay, here. So here we should enable the reference plane. Then this is already in the order, so we can start injector. Okay, so here I will make twin field atomizer. This is for the simple representation only, not the real time atomizer. Okay, but it will work for the real time also very well. So let's start. Okay, first I will select the any plane for the this one. Okay, then I will go to the sketch, then corresponding coincidence plane. So I will select just for this plane as a reference. So then it will move to the corresponding plane. Okay, so this is the representation point for the injector. So we can make different ways injector. I will make through the revolve method. Okay, so first I will make the center line from here. So I will make the injector length of about 50 mm. Okay, so this is the reference. Okay, then from here I am planning to design atomizer with around 5 mm liquid tube diameter. So from here, this is the revolve, so I need to make the length of 2.5. Okay, 2.5 mm. Okay, 0 degree. So that is the reference point. Okay, from here we need to start. Okay, so 25, sorry, 50, we need to have the 50 mm length. Okay, minus 90 degree. So then finish. Then I will create around 7.5 mm of 45 degree angle. Okay, then I will increase this to the corresponding endpoint. Then I will increase this to 2.50, means air is entering through the 0.5 orifice gap. So here I will keep the gap between the liquid tube and orifice exit about 1.25. That means h by d ratio I will explain detail. So diameter is 5 and 1.25. So I will keep 50 point, sorry, 51.25. Okay, and minus 90. Okay, then I will make the line up to this point. Okay, then I will create the around So we will trim also, no issues. So I will make the particular around 15 length with minus 45 degree. So I will keep the 45 degree. Okay, that's it. So from here we will joint up to the center line. Okay, this is the just I will explain here. So in the 2D plane, liquid will come here, gases will come here, so it will mix internally as well as externally based on the flow conditions. Okay, then I will give this as a atomizer sketch for understanding purpose. Okay, okay, fine. So then we will uh, create the revolve option to create the 360 degree. Okay, from the sketch. Okay, so we need to select the sketch and enable chain axis of the revolution. We can keep that as a center axis. So we will create the atomizer. Here we can see. Finish. Okay, so this is the simple atomizer. Okay, so I will make all the subpart into one folder. Combustion chamber, I am giving the folder name is combustion chamber. Here I will save the injector, sorry, atomizer. Okay, fine. So now we design the atomizer. In order to keep this in the particular like location and point, so we need to have the proper dimensioning. So here we will measure the dimension first. So here diameter is 20.61, 26.21. Okay, fine. So this is the basic diameter dimensions. So here we will design the cylinder with around 27 mm or 30 mm. Then we will modify the sketch based on the cylinder. Okay, now we will close this one. Now I will open another part. Here we will start the cylinder. So I already explained about the cylinder function. One more time I will explain here before starting the design. Cylinder is the main device in the combustion chamber, which will create the recirculation zone in the combustion chamber. So it will enhance the mixing. So I will show some of the results from experimental work, then you can understand clearly the importance of the solar. Yeah, so this is the slide. Here we can see, so this is the result from the experimental work. We measured the velocity using the PAV. Okay, here we can see, so the Reynolds number flow through the solar we increased. Here we can see the increasing the Reynolds number or flow through the solar, increasing the recirculation zone. I mean, here we can see the negative velocity also showing. That means it is bringing back the velocity field here negative. This is a positive here. This is the negative. So this is typically with increasing in the Reynolds number of the flow. Okay. So these are the typical plots at a different actual location from the solar exit. So here we can see this is the main function of the solar. Okay, let's start the design point. Okay, first I will start with the solar up diameter of 30. Then we will decide design 30 to around 60. Okay, 60 mm. Okay, Let's select any one of the plane. Let's start the sketch. So we will continue with our 30 mm first. So let's start the up diameter of 30. Okay, fine. So I will create the shoulder thickness of 10 mm. Okay, then we will create the solar veins. So first, so this is the center hub for the solar. Now I will extrude for this one up to 10. Okay, 10 mm distance. Okay, fine. So this is the hub. Okay, now we need to create the solar veins. Here I am creating solar veins with respect to any one of the plane, x or z. So I will create one parallel plane. Okay, then I will create the solar veins with some angle. Okay, parallel to the x-axis. So I will keep around uh, so 30 and 30 is 60, so let's keep 30. Okay, fine. So in this direction I kept. Okay, fine. So I created the parallel plane with respect to the x-axis for creating the solar veins. Okay, now we need to make a sketch in the parallel plane which we created. So here, okay, fine. Here I will make a 1 mm thickness of the vein. So let's start first. I will make some reference lines from here around. This entire length is 15, so 7.5. I will make 50 percentage of the length of the hub for the reference. Okay, I enter, then 180. Okay, fine. So from here the solar will come like this, with particular angle. So I will make with respect to the around 45 angle also we can create it, right? Okay, fine. So this will be more solar number. So I will create with respect to around. Okay, so first I will make some particular line around, like, yeah, and then I will make the angle. Okay, this I will make the angle with respect to the this plane. So I will make around 35 degree. Okay, fine. Or like we can still increase also 40 degree, or we can still reduce also 25 degree, like that. So 25 degrees more soul will be there, so I will keep 30 for the rest, for the understanding purpose, or 32 or something, or else, yeah. So this is like just a angle. So in upcoming videos I will explain about how to calculate the sul numbers, so right now I am making a reference with a random sul number, okay, of the solar. Okay, now I created this one. So from here we should have the 1 mm thickness, so for that one I am using offset method, so it will give the exactly the proper 1 mm. Okay, accept it. So then direction, okay, fine. Now I will trim this part also. Okay, here I will explain this line, otherwise I will increase this length to 25. Oh, it is increasing in opposite way, so it's fine, no issues. So I will draw a one more line up to that one. Okay, then now I will measure the angle also, whether we are getting same 30 degree or not. It should get 32 degree. Okay, whatever I kept to 32 degree, it's coming there. So now we need to make the horizontal line to create the solar. So here, so the thickness will be different, not a 1 mm, but for the understanding purpose it's fine. Yeah, 1.89. So now we need to trim out this part in order to get the proper swell veins. So I am taking the trim option. So trim. So we should trim unwanted part. Okay, now we can see the corresponding plane is created. So now we can see the different color. Then we need to exactly extrude up to this point. Okay, next extrusion. So I am doing extrusion here. So I will select this one. Now extrusion option will be there, extrude option. So chain. So from the corresponding sketch. So sketch you select. Okay, we selected. Okay, yeah, fine. Then we need to extrude single. So wait a minute, some sketch is having some error is there. We can see what kind of error it is. One more time I will try from sketch. Okay, fine. Yeah, coming. So we need to select properly. Yeah. So I will keep randomly up to around 15 mm or up to next. There will be a option finite extend or through next. Through next means it will complete up to the next point. Okay, here we can see through next. Okay, then I kept. Okay, so this is the one vein. So in order to create the swirl flow, we need to have the multiple veins. So for that one, we should use the pattern option. Okay, I will. So here, how we can do the pattern? Huh? So first we need to select the pattern option, then corresponding feature. Okay, here we have to do the pattern for the protection too. Okay, select it. Then the corresponding plane, then we need to select a circle or the square. So we need to make the pattern in the 360 degree in the circle matter. So just to create the one circle. Okay, then number of count here 8 is there automatically. Yeah, we'll keep 8, then we will see how it is coming, otherwise we will change the number of counts. Okay, enter. Yeah, here we can see solar is created. So this is simple step only. Here we can see solar is created. So in order to keep in the proper injector and the combustion liner, we should create outer and we should cut the inner part also. Now we'll cut the hub. Okay, for that one we should select the catch, the again with respect to the plane. I will select the corresponding diameter. It's already 30. I will keep around 1.5 mm thickness, so it has to be 27. Then we need to make the cut option finish, then extrude. Here there are option add and minus. We are cutting, so we need to take the minus option with respect to the corresponding plane to the up to the next. Okay, through next. Fine, enter. Okay, now we can see this is done. We created the solar. Now we made a cut inside for the hub. So now we will make the outer ring of the solar. Okay, let select one particular plane for okay, this one. So let's keep the to diameter with respect to the center point around 56. Now one more circle to have the ring up. After a design, then you come to know like how why I'm doing this one exactly. So okay, done now. Now we need to extrude that two part. Yeah,
So this direction coming, this direction is not coming. So let's change the dimensions here. Edit. So instead of 60, we will keep the smaller one, 58. Now we'll try that option. Finish control. So we need to add the material here. Yeah. So it's coming. So the overall thickness we will keep through the next. Sorry, we need to do one more time. Extrude 10 mm. No, 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 sorry. We need to make a extrude. So we need to delete this part. So extrude, add, yeah, 10 mm. So finish it. So we are getting right. So this is how we need to have the proper design. Otherwise, like it is difficult to fix in the other component, other part. So now we can cut it out this external part using the another one more cutout. So for that also we should make a sketch corresponding to this plane, and here we can select 58, and another one is more than 60 or something, 65. Let's keep 65. Let's try this one with this to remove the external vein. Okay, so then again cut, here we need to select cut option of sketch, extrude from the sketch. Okay, so 10 mm. Finish. Now we can see the proper solar. I will hide all the sketches, then you can see the proper. Okay, I will hide this base plane also. Now we can see the proper solar. Okay, so now I will save this part. So now we completed two important part of the combustion chamber.